All right, everyone, this is the start of Chapter 2, Section 2.1, Patterns and Inductive Reasoning. Feel free to pause, try the do now on your own, and resume the video when you're ready. The do now asks you to find the next two terms in the sequence. So you have 2, 4, 6, and then we're trying to find some sort of pattern here. All right, well, if you notice, 2 to 4 is plus 2, 4 to 6 is plus 2, 6 plus 2 would make 8, 8 plus 2 would make 10. Okay, if you take a look at the bottom here, 3 to 9, well, 3 to 9 could either be plus 6 or times 3. So it could either be plus 6 or times 3. So we got to figure out which one it is. Well, 9 plus 6 only makes 15. We're looking for 27. 9 times 3 is 27. 27 times 3 is 81. Okay, so we need to keep going here. And we need 81 times 3, which is 243. And then we need 243 times 3, which is 729. Vocabulary terms. We have inductive reasoning, conjecture, and a counterexample. Inductive reasoning is reasoning based on patterns that you observe. Okay, feel free to pause the video and get your definitions in. Conjecture is a conclusion you reach using inductive reasoning. It is an opinion based on your inductive reasoning. A counterexample is an example that shows that a conjecture is incorrect. So a counterexample disproves conjecture. Like I said, feel free to pause, get your definitions down, and resume when you are ready. What are the next two terms in the sequence? 45, 40, 35, 30. So it says, do the numbers increase or decrease? Well, from 45 to 40 to 35 to 30, we are decreasing. Does the amount of change vary or remain constant? Well, from 45 to 40 is minus 5. From 40 to 35 is minus 5. And from 35 to 30 is minus 5. So it is a constant. Which operation helps us form the next term? Well, if we look here, we just said subtraction will get us there. And which number helps us form this next term? Well, that would be 5. So it says find the next two terms in the sequence. Well, the next two terms would be 30 minus 5, which is 25. And then it would be 25 minus 5, which is 20. Using inductive reasoning continued. It says, look at the circles. What conjecture can we make about the number of regions 20 diameters will form? So this is the last part of our question. If you notice, we have one diameter going right down the middle of this green circle here. Let me see if I can make it stand out. One diameter. Okay, it goes through the center point of the circle from side to side. So we have one diameter, and it makes 2 regions. Next, we have not one diameter, but 2 diameters, and it makes 4 regions. Here we have 1, 2, 3 diameters, and it makes 6 regions. So, we have to make some sort of conjecture based on this. Each circle has blank as many regions as diameters. Well, we go from 1 diameter to 2 regions, 2 diameters to 4 regions, 3 diameters to 6 regions. So our conjecture is that each circle has twice as many regions as diameters. So if there's 20 diameters, how many regions would there be? 20 times 2, which equals 40 regions. Okay, we need to use inductive reasoning like this because it would take quite a long time to put 20 diameters through a circle and make it neat enough for us to comprehend, right? So we need to be able to use this type of reasoning. Using inductive reasoning, complete the table. What conjecture can we make about the 21st term? Okay, so let's complete the table first, and then we'll worry about the 21st term afterwards. Okay, so the letters in the sequence are red, white, blue. And then you notice red, white, blue, RWB, RWB. Okay, so the first term is R, the second term is W, the third term is B, the fourth term is back to R, fifth term is W, sixth term is back to B. So if you notice, we have cycles. RWB is one cycle, and then we start over again with another cycle, RWB. And then we would start over again with another cycle of RWB. And that would be the 7th, the 8th, the 9th term. Okay, so there are blank letters in the pattern before it starts repeating. Well, in one cycle, there's 1, 2, 3 letters. R is the first term, the fourth term, and not counting the ones I added at the end, because that was just an example. The first term, the fourth term, and the... I guess we would, because it would be R here, would be the 7th term. W is the second term, the 5th term, and using our patterns here, the 8th term. And B is the 3rd term, the 6th term, and the 9th term. The 21st term is, well, if we were to keep going, the 21st term is 1 more than a multiple of 3, 2 more than a multiple of 3, or a multiple of 3. Well, 21 divided by 3 is 7, right? So it is a multiple of 3. Now let's make a conjecture. The 21st term of the sequence is, what letter would it be? Well, if we take a look, which terms 1, 4, and 7 are not multiples of 3? 2, 5, and 8 are not multiples of 3. But 3, 6, and 9 are multiples of 3. Therefore, this must be the letter B. All right, collecting information to make a conjecture. What conjecture can you make about the sum of the first 30 odd numbers? Okay, well, if we take a look, number of terms 1. The sum, the result, and the pattern. We need to be able to complete this table. Okay. So if there's only one term, the only odd number would be 1. If we were to add 1 to nothing, it would just be 1. The number of terms, if there's 2 odd numbers, that would be 1 plus 3, because 3 is the next odd number. The result is 4. If there were 3, it would be 1 plus 3 plus 5, which makes 9. If there were 4 odd numbers, it would be 1 plus 3 plus 5 plus 7. Well, 1 and 3 makes 4, and 5 and 7 makes 12, which makes a total of 16. Then it would be, for 5 terms, 1 plus 3 plus 5 plus 7 plus 9. And we're just adding 9 to 16, which makes 25. Now we want to try and find 30 odd numbers all added together. Instead of writing this all out and finding the result, we need to come up with a pattern. Look at the number of terms and the result. There is a pattern there. If you notice, 1 term and the result was 1. The pattern, well, take a look. Isn't 1 times 1 1? If the number of terms is 2, isn't 2 times 2 4, which is the result? If the number of terms is 3, 3 times 3 is 9. The number of terms is 4. Well, 4 times 4 is 16. And if the number of terms is 5, well, 5 times 5 is 25. So if the number of terms is 30, then the sum of the first 30 odd numbers must be 30 times 30. And 30 times 30 gives you a result of 900. Now, we would never want to write all of the odd numbers, the first 30 odd numbers added together and add them all up. It would take a very long time. Finding a pattern, right, will only increase the production and the quickness that we can get to completing this question. Making a prediction. It says sales of backpacks at Jansport decreased over a period of 6 consecutive months. What conjecture can you make about the number of backpacks the company will sell in May? What about June? What about July? So if we notice, the sale of backpacks is decreasing, right? That was stated in the given information. If you check in the chart or the graph, it's also decreasing. Now, we don't need specifics here because we can't truly measure where these points lie on the graph. All we can take is estimates. So if we look, we go from about 11,000 to almost 10,500. Then we go from a little more than 10,500 to a little more than 10,000. And we keep dropping a little less than 9,500, down to a little less than 9,000, and then down to a little less than 8,500. So if we could say or make an estimate, we are approximately going down by 500 backpacks per month. Sorry about my dog, guys. If you can hear him. What conjecture can you make about the number of backpacks the company will sell in May? Well, from April to May, we could say they went from about 8,500. Following the rule that we just set in place, minus 500, there might be about 8,000 backpacks sold. And if there was June and July, we would go from 8,000 minus 500, which makes 7,500. And then we would go from 7,500 minus 500, which would make 7,000. Okay, these are how we make predictions given information from a graph. Okay. Finding a counterexample. What is a counterexample for each conjecture? If the name of the month starts with the letter J, it is a summer month. So here is the statement, or the conjecture. If it starts with the letter J, it must be in the summer. A counterexample of that would be January starts with J, but it is a winter month. So that disproves the conjecture. Remember, the counterexample disproves the conjecture. You can connect any 3 points to create a triangle. Well, we have 3 points here, and we absolutely can create a triangle between them. But we need a counterexample that disproves this statement. What about 3 points that are perfectly within a line? Those 3 points could never make a triangle. They can only result in a straight line. So there's your counterexample. Your exit slip. Again, why does this always happen with the exit slip? There we go. Clay thinks the next term in the sequence of 2, 4 is 6. Given the same pattern, Ott thinks the next term is 8. Stacy thinks the next term is 7. What conjecture is each person making? Is there enough information to decide who is correct? Well, Clay is going from 2 to 4 to 6. Well, that would be a pattern of plus 2s. Okay, so adding 2 would be Clay's conjecture C. And that would be the one right above it. 2 to 4 to 6 to 8 to 10 to 12 to 14 and so on. Those are all plus 2s. Ott thinks the next term is 8, from 2 to 4 to 8 to 16. And what do you notice he's doing? He's not adding by 2, he's multiplying by 2. So Ott's conjecture is A, multiplication by 2. Stacy thinks the next term is 7. So from 2 to 4 to 7 to 11 is Stacy's claim. And that would be choice B, adding by 2, then by 3, then by 4. Then if you add by 5, it would be 16. By 6 would be 22. By 7 would be 29. So that's Stacy's claim, is you're going to keep increasing the number that you add by. Now, all of these patterns work. They're all correct. So are two numbers enough to show a pattern? The answer is absolutely not, because all three of these predictions could technically be correct. All right, we're just unsure of which one it is. If we were given a third number, we would be able to determine which one right off the bat. But by only giving us 2 and 4, we have no idea. Okay, if they gave us 2, 4, and 6, then we can make a little bit of a better prediction, knowing that Clay's conjecture would probably be correct. If they gave us 2, 4, and 8, then we would be able to make the conjecture that maybe Ott's is correct. Or if they gave us 2, 4, and 7, then we would be able to say that Stacy would be correct. All right, but just giving us 2 and 4 is not enough info. Okay, everyone. Thanks for watching. Don't forget to